Hello folks, we are once again back with this exercise 7.5 and now we are going to do the problem number 16 which is there on the board. It says that I is the integral of 1 over x times x raised to n plus 1 dx. It's a very characteristic problem. In this exercise itself, we will see that this kind of problem is coming 2 or 3 times in the exercise. So every time that such a problem comes, we have to do the same kind of substitution that we will be doing. It is a substitution that we have to do and then convert it into a favorable form, then use partial fraction. That's how we are going to do it. So the substitution that we will be doing in this part will be, that is, we have a raised to n and a linear, a product of a linear and raised to n. Whenever you get such a thing, we are always going to follow this strategy. As I told you, it is coming twice or thrice in the exercise, and even later in the later exercises it is coming. So wherever it comes, we have to remember that this is a substitution that we should be doing. So therefore here we have this x. We will be substituting the u as, so let u be x raised to n plus 1. That will be our substitution. Now with that you will be able to get the derivative. Du over dx is going to be n x raised to n minus 1 dx. So probably you can have du over n equal to x raised to n minus 1 dx. Now with this in mind, let's multiply both the numerator and the denominator by x raised to n minus 1. As a result, this integral will get converted as x raised to n minus 1 dx over, now this can club together, a raised to m times a raised to m is a raised to m plus n. So that way this will become x raised to n times x raised to n plus 1. So now we can convert the integral. The integral will now become dx raised to x, dx times x raised to n minus 1 is du over n. So that is done. X raised to n can be called as, from here it's clear that x raised to n is u minus 1. So x raised to n is u minus 1 and x raised to n plus 1 we have already assumed it as u. So this is 1 over n du over u times u minus 1. Now these are two linear factors in the denominator. In order to get the integral, we will use partial fraction, and for that let's call this particular part, consider 1 over u times u minus 1 as a over u plus b over u minus 1. This is what we do for two linear factors, and we know that this is the LCM. So this entire fraction has to be multiplied by u minus 1 and this entire fraction has to be multiplied by u. So as a result, this will become a times u minus 1 and b times u, and since both of them will be having the same denominator, we will write it like this. U times u minus 1 from the denominator can cancel and we are left with a times u minus 1 plus b times u to be 1. In order to get the a and b value, let's call u as 1. When u is 1, this is gone. So you will get b times u, which is b times 1 as 1. So b is done. Then you can call u as 0. If u is 0, then this is gone. So you will get a times negative 1 as 1, which means a is negative 1. So you've got now both a and b value. So it is this that you have to take care. So your I now becomes integral of, so let's be careful to put all the parts together. 1 over n is there, so that should be there, and du over u minus 1, we can write it like this. It's a over u, that is negative 1 over u plus 1 over u minus 1 du. That means your integral is going to be 1 over n overall and 1 over u du, negative 1 over u du, and positive 1 over u minus 1 du. That's it. So your integral, that's very easy. Your integral is negative log modulus u plus log modulus u minus 1 plus c. Now u, because it's our creation, so let's get back to the value that it is. It is x raised to n plus 1. So let's call it as negative log x raised to n plus 1 plus log x raised to n plus c. So that's about this particular substitution, and this is how you're going to get the answer after doing the substitution back. And of course, because it is, as I always tell, log has its own immense properties, so you can use any of the properties and try to simplify it further. So this is how you go about doing the work. That should be all for this video. With the next problem, let's meet in the next video. Thank you.